All right, in the last video, we talked about the trigonometric functions and their derivatives. And in this section, we are going to be talking about exponential and logarithmic derivatives. Just like in the previous section where I said that you needed to memorize those 6 trig functions, their derivatives, the same is going to be asked in this section, that you memorize these 4 exponential and logarithmic derivatives. So here are the 4 I'm talking about. First one is the derivative of e to the x. That derivative is actually just e to the x. So it's actually just the same thing. The derivative of the natural log of x is 1 over x. These two are the big ones that are actually used the most. The next two, you still need to memorize them, and we'll have probably an equal amount of problems with them. But as we move forward, there's a lot more functions with e to the x and natural log of x in them than there are. This is called the base a to the x or log base a to the x as well. Also, just one thing to note, when we talk about e to the x, it's most likely when we see a function, we won't always just see like 3e to the x, but we might see a function like 3e to the negative 2x. Okay. And so in future videos, we'll talk about what's going to happen when the exponent is not just a regular x. That's going to require some different things. In the same way that if this function down here was not just the natural log of x, but if it was, I don't know, 1/2 x natural log of 3x, it changes just a little bit of what we're going to be doing. However, for now, we're just going to start with the basic ones where you always only have e to the x or natural log of x. But just note that there is possible we could have more stuff in that exponent or more stuff inside of that natural log function. In the same way, in the previous video when we looked at the trig functions, we won't always just have the cosine of x. We might have the cosine of 3x squared. So that's going to change these derivatives just a bit. It's just going to basically add extra on to these derivatives. These are all still true. It's just if we have more stuff in it, we have to do an additional thing as well. So that will be coming with the chain rule. All right, and then the next one, if we're talking about base a to the x, that's going to be a to the x natural log of a. Again, it's not used as much. However, you still need to know what that is. And if we're talking about log base a of x, that is 1 over x natural log of a. You might be wondering why these two are so much different, because e to the x and a to the x are actually kind of the same thing. The number e, well, it's just actually a constant. That constant turns out is just like 2.718, something after that. So really, this is just saying 2.718 to the x, so on and so forth. And in this particular derivative, a is a number, a is a constant. So you might be wondering, why is it so different? Why do I have that extra natural log of a on it? Well, the reason why is technically you can actually still use this rule for e to the x. It's just if you were to do the derivative of e to the x using this rule, it would be, so a to the x, which would be e to the x, natural log of e, and the natural log of e just turns into 1 because natural log is log base e, so natural log of e actually just goes away. This just goes to 1, so that's why we're left with just e to the x. So it's just kind of a shortened form of that. And in the same way, if we look at this log base a of x, we actually would apply the same rule for this natural log if we were doing it. So if we were to calculate natural log using this rule here, well, it would still be 1 over x, but then it would be the natural log of the base a, which actually turns out to be e when we're talking about natural log. Because if you remember, natural log is actually log base e of x. It's the same thing. So it would be like saying log base e of e, and so they would actually just cancel out. It just goes to 1 as well. So that's why you'd end up with 1 over x. So that's why these are different. And again, you actually will use e to the x and natural log x way more than you'll ever use like 2 to the x or log base 2 of x or something like that. But you do need to know all 4 of them. Just note that the ones that we'll work with mostly are e to the x and 1 over x. So got those down really well. All right, let's go ahead and do some problems using these. And we'll also be incorporating as we go some of the power rules and product rules, quotient rules, all that stuff so far. So let's start with our first one. This derivative, f prime of x. There isn't really any special rules we need to use here. The 2 just hangs out in front of the e to the x, and the derivative of e to the x is simply e to the x. So it's just 2e to the x. Minus, here is our a to the x. So a to the x is a to the x and then natural log of a. So in this case, it's going to be minus 8 to the x and then natural log of 8. The natural log of 8 is actually just turned out to be some constant. This is good here. Let's go ahead with our next one. So 3 to the w log of w. All right, now when we calculate this one, r prime of w, first thing to note is that we have 2 sort of functions here. We got an f and a g. So this is a product rule because we're multiplying. So the first one, 3 to the w, we're going to take that derivative first. 3 to the w, natural log of 3 is the derivative of the first term. We're going to keep this log of w plus, because it's a product rule, 3 to the w. And then we have log of w. Now notice in the rule on this one, the derivative of log base a of x, there is no a there, right? There's nothing there. You might want another refresher here. If you just have a log x, or in this case log w, there's actually an invisible 10 right there. So there's an invisible 10 here, because if you just see log, that implies log base 10. So another reminder on that. So if we have just log, so it's going to be times 1 over w, because that's in the x place, natural log of 10, because the a, the little base there, is 10. So that's what it's going to look like. Don't worry about simplifying on this one. There's not a lot you can do. So keep it there. These, a lot of them aren't really practical examples, but they are good examples to help you just get repetition and learning these derivatives. Okay, let's try another one. This one will be y prime. This is just z to the 5th, so it's 5z to the 4th. Minus, and now we have an f times a g, right? We got a product rule. I'm going to put a parenthesis because it is minus this entire thing. So put a parenthesis and put the whole thing inside of that. So the derivative of e to the z is just going to be e to the z. Natural log of z, because that stays the same. Plus, well, the original f there, which is just e to the z still. And the derivative of the natural log of z is 1 over z. And all of that's in parentheses. And if you want to just go ahead and distribute that, negative e to the z natural log of z minus e to the z. And actually, you could write this e to the z over z. Put it that way. Multiply it. All right, let's look at the next one. Here's a product rule, or sorry, quotient rule. Remember, quotient rule is f over g equals f prime times g minus fg prime over g squared. So this one we have h prime of y. The derivative of y is simply 1. So 1 times the denominator of 1 minus e to the y minus y times the derivative of the bottom there is just going to be negative e to the y, because the 1 goes away, and then the derivative of e to the y is just e to the y over 1 minus e to the y quantity squared. And we could do just a little simplifying here. Might as well go ahead and just drop that 1 in front. So it just means 1 minus e to the y plus e to the y. Or you could do y e to the y, either way. Over 1 minus e to the y squared. All right, let's go ahead and do a couple more, just to practice these. Next one up, r prime of w. 4 to the w is the derivative of that is just 4 to the w, natural log of 4. Minus, this is not a product rule or anything, it's just 5 log base 9 of w, so we can just keep the 5 there. 5, and then it's 1 over, in this case w, because there's no x, it's w, natural log of 9. And really the only thing to do to simplify this is maybe just write that 5 on top. So we got 4 to the w, natural log of 4, minus 5 over w ln of 9. And that's it. All right, let's tackle another quotient rule here. Y prime equals f prime, so the derivative of the top there is actually just 5e to the x times the denominator, 3e to the x plus 1, minus original f there on top, times the derivative of the denominator, which is just 3e to the x because the 1 goes away, over 3e to the x plus 1 quantity squared. For right now, I suppose it's probably fine to leave it like this, but I'm just going to go over and show you how you would simplify this one, just so you remember how to do some of these things. When we distribute here, that would become 15 e to the, and remember when you multiply things with the same base, you add the exponents. So the e to the x times the e to the x would become e to the 2x, because you would add x plus x. And then that would become plus 5e to the x. And here we would just multiply, so it would be minus 15 e to the 2x. Because again, we add them when we multiply. Bottom, we're not going to FOIL that one out, as much fun as that would be. But we can see we actually get a cancellation here. So it just becomes 5e to the x over 3e to the x plus 1, quantity squared. And I think that's pretty much it. We could go through more, but basic idea there. I think you guys got a handle on it. Actually, well, let's do this one more. Sorry, somehow this one got missed. It's good to see this product rule here. So let's go ahead and try this. F prime of x is derivative of 3e to the x is just 3e to the x. But we do have a product rule, f and a g here. Look at those as two different functions. Again, I like to keep the 10 with the x cubed. Just consider that my f. So plus, and then we got a product rule, first derivative of the first one, which would be 30x squared. And if you want to throw this whole thing in parentheses, you can. It's kind of helpful to just help you keep track of it, I think. So you do the derivative of the first one times the second, ln of x, plus original first one, 10x cubed. Derivative ln of x is 1 over x. So then when we write out our answer here, 3e to the x plus 30x squared ln x. We can just write that as one fraction there. This would just go up on top. And would actually just cancel out with one of the x's, so that would leave us with just 10x squared. And there's our solution. All right, hopefully that made pretty good sense to you. Again, you do need to memorize these. Best way to do it is just keep doing practice. So good luck on the assignment. I think the last problem on the assignment has both a product and a quotient rule, I believe. So give that your best shot. But again, on the last question, I think it's number 12. Yeah, you have a product rule within a quotient rule. So do your best on that as you can, and we'll post the solutions for that. All right, see ya.